Hi, this is RanellaGrace Puyat, BSIT, and my second topic in my course project, Data Communications and Networking Tree, is the STP or Spanning Tree Protocol. So, network redundancy is the key to maintaining network reliability. Multiple physical links between devices provide redundant paths. The network can then continue to operate when a single link or port has failed. Redundant links can also share the traffic load and increase capacity. Multiple paths need to be managed so that the layer 2 loops are not created. The best paths are chosen, and an alternate path is immediately available should the primary path fail. The Spanning Tree Protocol or STP is used to create one path through the layer 2 network. So, issues with layer 1 redundancy or MAC database instability. This is a sample illustration of TTL or time to live. So, Ethernet frames do not have a time to live or TTL field like layer 3 IP header has. This means that Ethernet has no mechanisms to drop frames that propagate endlessly. So, this can result in MAC database instability. Okay. This is an example. For example, the example of result in MAC database instability is number 1, PC sends a broadcast frame to S2. So, the PC1 sends a broadcast frame to S2, which is the switch 2. And then, the switch 2 updates the MAC address table on PC1's MAC address port on address port 11. So, this is the port 11. And then, the S2 or switch 2 forwards the frame out of all ports except the port that the frame came in on. So, S1 and S3, this is the S1 and S3, receive the frame on a trunk and update their own MAC address tables that PC1 reachable. PC1 is reachable through the trunk port. And then, the S1 and S3 send the frame out of all the ports except the port that it came in on. When S1 sends the frame out of port 2 or trunk 3, this is the trunk 3, S3 updates the MAC address table to reflect that PC1 is now reachable through the port 1. Okay. This is the port 1. A host code in a network loop is not accessible to other hosts. Due to constant changes in MAC address, table switches S3 and S1 do not know which port to forward frames. So, this is also a sample illustration of broadcast storm. The broadcast storm so many broadcast frames in a layer 2 loop that use all available bandwidth and make the network unreachable for legitimate network traffic. It causes a denial of service or DOS and can develop in seconds and bring the network down. Okay. An unknown unicast frame is when the switch does not have the destination MAC address in MAC address table and has to broadcast the frame out of all ports except the port that frame was received on the ingress port. Unknown unicast frames send onto loop network that can result in multiple frames arriving at the destination device. So, Spanning Tree Protocol creates one logical path through the switch network or all destinations on the network. It blocks the redundant paths that could cause a loop. And then, the STP sends bridge protocol database data units or BPDUs between layer 2 devices in order to create the logical path. So the port on S2 blocks so that traffic can only flow one way between any two devices. When trunk 1 fails, the block port on S2 is blocked and traffic can flow between S2 and S3. Spanning tree algorithm, port rows, and root bridge. So this is the root port, the designated port, again the root port, the designated port, and the alternate port. So the root bridge, one layer 2 device in the switch network. The root port means one port on the switch that has the lowest cost to reach the root bridge. Root bridge is also the lowest bridge ID becomes the root bridge, okay? And then the designated port, this is the designated port, and here is selected on a per segment, each link basis. So, based on the cost to get back the root bridge for either side of the link. The alternate port, or RSTP only, backup port for designated port. So, this is the backup port. And then, the backup port, spanning tree algorithm. Root path cost. Root path cost is used to determine the role of the port and whether or not traffic is blocked. We can modify with the spanning tree cost interface command. So note that the default spanning tree cost is 19. And we can set the spanning tree cost to the Cisco configuration. So I have here a simple network showing switch 1, 2, and 3. So I am going to show you how to configure the spanning tree. And now, let us see first the port that is used in each switches. So for S2, we have used the switch port 1 and 2, the fast Ethernet 1 and 2, same as in S1 and S3. So the first configuration is config D, and then enter the port number, and then cost. Let's say 25. And then enter exit, and then exit, and then show spanning. So the route ID priority is 32769, and then the bridge ID is 32769, and the address is this. Okay. This is for, and then the route ID is This is for F01 and then next interface F01 and then spanning cross 25 for example, and then let's see show spanning and then next interface F02 spanning cos 25 exit show spanning Okay, to identify the root bridge in these switches, for example, to show spanning through. Okay, it is indicated in the configuration that this bridge is the root. Okay, so S2 is the root bridge. And after the S2 and S3 is changed, the BPD use, STP determines that the port 2 on S2 becomes the designated port, and S3 port 2 becomes the alternate port, thus going into blocking state. So there is only one path through the switch network. So from the given example that I had said earlier, we are now going to determine the designated and alternate ports. Remember that port states are based on the path cost back to the root. So here in our network, the root bridge is the S2. So therefore, the designated port will be the port 1 and the port 2. So, designated port. This is the designated port. And the alternate port is the alternate port is going to the blocking state, so there is a path through the switch network. This is the alternate port. .802.1d BPDU frame format. So these are the fields that of BPDU frame format. The protocol ID, which is the type of protocol being used, set to 0. The version is the protocol version set to 0. And then the message type of message set to 0. And then flags, topology change or TC, bit signals, topology change acknowledgement or TCA bit, use the configuration message with the TC bit set has been received. The root ID is the root bridge information. The root path cost is the cost of path that the switch is sending to the configuration message to the root bridge. And then the bridge ID includes the priority, extended ID system ID, and MAC address ID of the bridge sending the message. The port ID, port number from which the BPDU was sent. The message age is the amount of time since the root bridge sent the configuration message. And then the max age is when the current configuration message will be deleted. And then the hello time is the time between the root bridge messages, and the forward delay is the time the bridges should wait before going to a new state. So this is a sample of PPTU propagation and process. So number 1, when a switch is powered on, it is assumed that in the root bridge until the BPDUs are sent and STP calculations are performed. S2 sends back the BPDUs. S3 compares its root ID with the BPDU with S2. S2 is lower to S3 updates its root ID. And then the S1 receives the same information from S2 and because S1 has a lower BID, it ignores the information from S2. So when S3 sends the BPDUs out of all ports, it indicating the S2 is root bridge. And then S2 compares the info from S2, so S3 still thinks that is still a root bridge. So S1 gets the same information from S3 that S2 is the bridge, but Because S1 has a lower bid, the switch ignores the information in the BPDU. S1 now sends out BPDUs out all ports. The BPDU contains information designated S1 as root bridge. So S3 compares the info from S1, so S3 sees the bid from S1 is lower than its stored root bridge information, which is currently showing that S2 is root bridge. So S3 changes the root ID to the information received from S1. And then S2 compares to the info of S1. So S2 now sees the bid from S1 is lower than its own bid. S2 now updates its own information showing S1 as a root bridge. So remember that after the root bridge has been determined, the port rows can be determined because those rows are determined by total path cost back to root bridge. Extended System ID. If priorities are all set to the default, lowest MAC address is the determining factor in lowest bid. The priority value can be modified to influence root bridge election. Remember that the lowest BID becomes root. Types of spanning tree protocols. The 802.1d is the 1998 original STP standard. The CST is the one spanning tree instance. The PBST Plus is Cisco update to 802.1d. Each VLAN has its own spanning tree instance. The 802.1d is the 2004 version, updated bridging and STP standard. The 802.1w or RSTP improves convergence by adding new roles to ports and enhance BPDU exchange. Rapid PBST Plus is Cisco enhancement of RSTP using PBST Plus. And the 802.1s MSTP is the multiple VLANs can have same spanning tree instance. So the characteristics of spanning tree protocols are the following. So there are STP type, the standard, and the resources needed, the convergence, tree calculations. So for the STP, the standard is 802.1d. The resources needed is low, convergence is slow, and tree calculation, all VLANs. PBST Plus, standard is Cisco. The resources needed are high, and the convergence is low, and tree calculation is per VLANs. RSTP is 802.1w. The resources needed is medium, the convergence is fast, and the tree calculation is all VLANs. Rapid PBST Plus, the standard is Cisco, the resources needed are high, convergence is fast, and VLANs is the tree calculation. MSTP 802.1s is the standard, and then the resources needed is medium or high, convergence is fast, and then the tree calculation per instance. Overview of PBST Plus. Original 802.1d defines a common spanning tree. One spanning tree instances for the switch network, no matter how many VLANs, no matter how many VLANs. Okay, no load sharing. One uplink must block for all VLANs and low CPU utilization because only one instance of STP use calculated. So, Cisco PVST Plus, each VLAN has its own spanning tree instance. One port can be blocking for one VLAN and forwarding for another VLAN. And then, can load balance and can stress the CPU if a large number of VLANs are used. Extended System ID and PVST Plus operation. The Extended System ID field ensures each switch has a unique BID for each VLAN. So the VLAN number is added to the priority value. For example, VLAN 2 priority is 32770, default value is 32768, plus the VLAN number of 2 equals 32770. So can modify the priority number to influence the root bridge decision process. Reasons to select a particular switch as root bridge. Switch is positioned such that most traffic patterns flow towards the particular switch, and switch has more processing power better CPU. Switch is easier to access and manage remotely. Overview of Rapid PVST Plus. So, Rapid PVST Plus speeds up STP recalculation and converges quicker Cisco version. So, the two new port types are the alternate port, DIS, and the backup ports. Independent instance of RSTP runs for each VLANs. Cisco features such as uplink pass and backbone pass are not compatible with switches that run RSTP. RSTP BPDUs. RSTP uses Type 2, version 2 BPDUs. Original version Type 0, version 0. The switch using RSTP can work with and communicate with the switch running the original 802.1d version. BPDUs are used as a keep alive mechanism. 3 missed BPDUs indicates lost connectivity. So this is an example illustration of the edge port. The pink circle stands as the edge port. So, it has a device connected, never another switch. So, immediately goes to the forwarding state and functions similar to a port configured with Cisco port pass. The spanning tree port pass command. So, another illustration of link types. So, the shared is port in a hub duplex mode connecting a hub to a switch. And the point-to-point is a port in full duplex mode connecting from one switch to another switch or from a device to a switch. So the legend is the point-to-point is the pink one and the yellow is the shared one. So the router is shared, the hub is shared, and the switches are point-to-point, and the PCs are point-to-point. Catalyst 2960 default configuration. So, these are the list of the features of the Catalyst 2960. So, the feature is enable state, and the default setting is enabled on VLAN 1. So, spanning tree mode, PVST plus, and then the switch priority is 32768. The spanning tree port priority configurable on a per interface basis is 128. And then spanning tree port cost configurable on a per interface basis is 1000 MBS 4, 100 MBS 19, and 110 MBS 100. So spanning tree VLAN port priority is configurable on a VLAN basis. 128 is the default setting. And the spanning tree VLAN port cost configurable on a per VLAN basis is same as the default setting of the spanning tree port kiosk configurable on a per interface basis. And the spanning tree timers is hello time 2 seconds. The forward delay time is 15 seconds. The maximum aging time is 20 seconds and transmit hold count is 6 BPDUs. So this is a configuration and verifying the bridge ID. You only have to type the show spanning tree and then the bridge is the root, so it indicates that the certain switch is the root. So two ways to influence the root bridge election process. Use the spanning tree VLAN X root primary or secondary command and then change the priority value by using the spanning tree VLAN X priority X command. And then verify the bridge configuring and verifying the bridge ID. So, two ways to influence the root bridge election process is first is to use the spanning tree VLAN X root primary or secondary command or change the priority value by using the spanning tree VLAN X priority X command. So, to verify the bridge ID and root bridge election by using the show spanning tree command. So, we have discussed earlier that the S2s are bridge root bridge. So, we are going to confirm show spanning tree. Okay. It says that the bridge is the root and the priority is 32769. Okay. You have to copy this. To 769. Okay. To change, for example, let us make the switch 1 be the priority. Okay. And then let us apply the first method, which will use the command. Let us enter the config D first and then apply the spanning tree VLAN X. So we have default VLAN 1 root primary. Okay. So let us double check. Spanning tree VLAN 1 root primary 3. Okay. Then enter. And then end. Okay. So now let us check show spanning tree. Okay. So now our S1 is the new bridge, the new root bridge. Okay. The second, and let us check the S2 if it is still the root bridge. Show spanning. Okay. This is not the root bridge anymore because we have transferred the Okay, now we are going to apply the second method of configuring and verifying the bridge ID. So, as you have remembered, we have the root bridge on S2, which is transferred to S1. So now our root bridge is the S1. Let us check first and enable, and then show spanning tree. Okay. It says that this bridge is the root, and then our priority number is 24577 and priority is 24576. So we have to copy this and paste it later to the next switch. So now we are going to transfer the priority to the S3. Okay. Let us exit first. And then enter the config key. And then apply the method 2, which is spanning 3 VLAN 1 and then priority and then the 24576. Okay. And then let us check show spanning port pass and BPDU guard. Port pass is used on ports that have end devices attached. It puts a port in forwarding state and allows DHCP to work properly, while the BPDU guard disables a port that has port pass configured on it if a BPDU is received. So let us configure in the port pass and BPDU guard in Cisco Packet Tracer. Have to click on switch 2. So we have to enter the configuration mode, and then internet interface has Ethernet 11 for PC1. And then spanning tree port pass. Okay. And then spanning tree BPDU guard enable. Okay, next. Next is PVST plus load balancing. So, to start, we have to click on S3 and then enable. And then enter the configuration mode. And then spanning tree VLAN 20 root primary. Okay. And then spanning 3 VLAN 10 second root secondary. Okay. And then, spanning tree. VLAN 20 priority. Okay. And then we are going to click on S1. Then enter the configuration mode. And then spanning tree. Do the same process to RS1 or switch 1. Okay. Spanning tree. VLAN 10. Okay. And then VLAN 20. Secondary. Okay. And then spanning tree VLAN 10 priority. Okay. And then show spanning tree active. Ay, so exit muna tayo. So, show okay. In S1, the default VLAN 1, and then the next VLAN is 10. This bridge is the root because we have set the VLAN 10 as root primary. And then in VLAN 20, we have set this as root secondary. Okay. Enable the spanning protocol. Let us check the S3 if we will get the same output. Show spanning active. Okay. 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 This bridge is the root bridge. Okay. And the next step is in S1, show running config okay, it is building configuration. Okay. The spanning tree VLAN 10 priority is 4096 and the priority for VLAN 1 is 204080 and for the VLAN 20 priority is 28672. Spanning tree mode. Rapid PBST Plus supports RSTP on a per VLAN basis. Default on 2960 is PBST Plus. The spanning tree mode Rapid PBST puts on a switch is the Rapid PBST Plus mode. The spanning tree link type point-to-point interface commands designates a particular port as a point-to-point link, does not have a hub attached. The clear spanning tree detected protocols privilege mode command is used to clear STP. So let us do this in Cisco Packet Tracer. Click on S1 and then enable and then config T. And then spanning tree repeat PBST and then interface F02 and then spanning tree link type point to point and then end. Okay, and then show when and then show spanning tree VLAN 10. Okay. Show spanning tree VLAN 10. Okay. So, spanning tree enabled protocol or STP. Next topic is analyzing STP topology. So, to start, analyze the STP and then discover the layer 2 topology by using the command show CDP neighbors. And then prepare the expected layer 2 path by using the use STP knowledge. And then verify the root bridge by show spanning tree VLAN and confirm the layer 2 path by show spanning tree VLAN. And then next is overview of STP status. So to display the overview of STP status, we only need to enter the command show spanning tree VLAN and the VLAN number. Let's say it's 100. So for example, show spanning Okay. So it says that no spanning tree instance exists because we do not have VLAN 100. So let us try in VLAN 1. Okay. So the spanning enabled root protocol is RSTP in VLAN 1. So let's say in VLAN 10. Okay. In VLAN 10, we also have spanning tree enabled protocol RSTP. Let us try in VLAN 20. Okay, and then in VLAN 30. Spanning tree failure consequences. Never turn STP off. This can cause switch network to be unusable. So remember that there is not a TTL mechanism or time to live mechanism at layer 2. And then repairing a spanning tree problem, manually remove redundant links, physically remove the cable, or through configuration if possible. So determine and repair the cause of the spanning tree failure. If unable to determine the problem, reinstall cables one at a time or enable the ports to locate the issue. Switch stacking concepts can connect up to 9 3750 switches. On the switch, the stack master controls the operation of the stack. If this switch goes down, a new stack master is elected. Appears on one entity to the network. Stack is assigned on one IP address. Each switch has a unique stack member number. Can configure a priority value to determine which switch is stack master, and the highest stack member priority value is the stack master. The stack master has the save and running configuration files for the entire stack. Only one configuration file to manage and maintain. Spanning tree and switch stack. Each stack appears as one spanning tree instance. Can add switches without affecting the STP diameter. The maximum number of switches data must cross to connect between any two switches. So IEEE recommends a maximum diameter of 7 switches for default STP timers. Default STP timers are hello, 2 seconds. So max age are 20 seconds. And forward delay timer is 15 seconds. So these are the new terms and commands that we have used in this chapter. So the broadcast storm, MAC database instability, spanning tree algorithm, spanning tree protocol, BPDU, loop-free path, RSTP, MSTP, IEEE 802.1d, root port, designated port, alternate port, the backup port, the spanning tree instance, the BID, the root ID, the bridge priority value, the root path cost, the show spanning tree, the extended system ID, and CST, PVST, 802.1W, rapid PVST, 802.1S, edge port, point-to-point link, shared link, spanning tree port pass, spanning tree VLAN root primary, and then the secondary, and then the spanning tree VLAN priority, spanning tree BPPDU guard enable, spanning tree active, spanning tree mode rapid PVST, and spanning tree VLAN, and then the spanning tree VLAN point-to-point, and then the clear spanning tree detected protocols, and show CDP neighbors, switch stack, and stack master.